connection with math. This will lead us to discover that we have a tree that is not a tree. What is it? Let's find out. Forestry has a lot of subjects. From first year to fourth year, it is expected to have subjects related to math. Trees itself has math. By that, studying forestry would allow oneself to go down through the topics of trees, ecosystems, and many more that has a connection with math. In this video, we'll only tackle a shallow ideas about how forestry involves math in its existence. First, we have forest botany, wherein you would find the topics about how to trace the evolution of a species. In forestry, patterns cannot only be seen in trees' trunks, leaves, and flowers. Pattern is likewise useful in terms of figuring out the taxonomy history of species. This topic can be found in forest botany. A phylogenetic tree is a diagram that represents evolutionary relationships among organisms. Phylogenetic trees are hypotheses, not definitive facts. The pattern of branching in a phylogenetic tree reflects how species or other groups evolved from a series of common ancestors. In trees, two species are more related if they have a more recent common ancestor, and less related if they have a less recent common ancestor. Phylogenetic trees can be drawn in various equivalent rates. Rotating a style about its branch points doesn't change the information it carries. When we draw a phylogenetic tree, we are representing our best hypothesis about how a set of species or other groups evolved from a common ancestor. In a phylogenetic tree, the species or group of interest are found at the tips of lines referred to as the tree's branches. For example, the phylogenetic tree above represents relationships between 5 species, A, B, C, D, and E, which are positioned at the ends of the branches. The pattern in which the branches connects represents our understanding of how the species in the tree evolved from a series of common ancestors. Each branch point, also called as internal node, represents a divergence event or splitting apart of a single group into 2 descendant groups. At each branch point lies the most recent common ancestor of all the groups descended from that branch point. For instance, at the branch point giving rise to species A and B, we would find the most recent common ancestor of those 2 species. At the branch point right above the root of the tree, we would find the most recent common ancestor of all the species in the tree, A, B, C, D, E. Some tips for reading phylogenetic trees. You may see phylogenetic trees drawn in many different formats. Some are blocky, like the tree at left below. Others use diagonal lines, like the tree at right below. You may also see trees of either kind oriented vertically or flipped on their sides, as shown for the blocky tree. Secondly, we have forest measurements and statistics, wherein you can find how to measure trees' height and diameter. Measuring height is surprisingly simple. Now let's get started. Choose a tree and have your pen. After that, stretch out your hand, hold your pen the same to the tree. Make sure that the top of your pen is aligned with the top of the tree. Likewise to its lowest part, make sure that the pen's lowest part is the same with the tree's lowest part. After making sure that the edges of the pen is the same with the tree, sway down your pen to the left part. Where the top of the pen lands, stand to that part with your meter stick. You can now start measuring the height of the tree by measuring how tall your chosen tree is. In this video, the height of this cypress tree is 7 meters tall. Let's move on to measuring the diameter of a tree. Begin by measuring the height of a tree to 4.5 feet above the ground. Mark where the 4.5 feet ends, then with that mark you can start measuring your tree. Before finding out how much the diameter of your tree is, you must measure its circumference first, then divide with pi or 3.1415. In this video, I got 75 inches. I divided it with 3.1415. It resulted with 24 inches. By that, our diameter for this mango tree is 24 dBH or diameter at breast height. Lastly, we also have problem solving in forestry. This formula is used to measure the basal area of a tree. BA stands for basal area. It is the sum of the outside bark cross-sectional area at the breast of height in a given area. A problem example. You were able to measure two stumps whose diameters are 40 cm and 55 cm respectively. What are the basal areas of the two stumps? Here is the solution. The basal areas are, for 40 cm we have 0.1257 square meters, then for 55 cm we have 0.2376 square meters. Wow, that's a lot of math for two subjects. This only proves that forestry and math has a genuine connection with each other. All in all, these are some of the patterns, statistics, and problem solving you could find while studying forestry. Thanks for watching!